24 volts lighting control bypass switches are considered Class 2 circuits. Class 2 circuits operate at less than 100 volts and are used for control and signaling purposes. It is permissible to strap the low voltage cable to power conduits provided certain conditions are met. Firstly, the power conduits must be properly grounded. Secondly, the low voltage cable should not be in direct contact with the power conductors. Thirdly, the low voltage cable must be protected from physical damage, either by the power conduits themselves or through other protective measures. Alternatively, independent support methods can be employed for the low voltage cable. These methods include using cable trays, wire mesh, or other approved support systems. To elaborate on Class 2 circuits, it is essential to understand their characteristics and limitations as defined by the National Electrical Code, or NEC. The NEC provides guidelines for safe installation practices to minimize the risk of electrical hazards. Class 2 circuits, as defined in Article 725 of the NEC, are power-limited circuits that are designed to reduce the risk of electric shock and fire. These circuits are typically used for control, signaling, and communication applications where the voltage and current levels are low enough to be considered safe under normal operating conditions. The voltage limit for Class 2 circuits is typically 30 volts alternating current or 60 volts direct current, although there are exceptions depending on the power source and specific application. The power limitation is typically achieved by using power supplies that are designed to limit the available current to a safe level in the event of a fault or overload. Class 2 power supplies are required to be listed and labeled for Class 2 applications, and they must meet specific requirements for output voltage, current, and overload protection. When installing Class 2 circuits, it is important to follow the NEC guidelines for wiring methods, conductor sizing, and overcurrent protection. Conductors used for Class 2 circuits must be rated for the voltage and temperature of the application, and they must be protected from physical damage. Overcurrent protection, such as fuses or circuit breakers, must be provided to protect the circuit from overloads and short circuits. The size of the overcurrent protection device must be selected based on the ampacity of the conductors and the requirements of the equipment being powered. When running Class 2 cables alongside power conduits, it is important to maintain proper separation to prevent interference and ensure the safety of the installation. As mentioned earlier, the NEC allows low voltage cables to be strapped to power conduits, provided that the conduits are properly grounded and the low voltage cables are not in direct contact with the power conductors. This requirement is intended to prevent the low voltage cables from becoming energized in the event of a fault in the power circuit. To ensure proper separation, it is recommended to use cable ties or other approved methods to secure the low voltage cables to the conduits. The cable ties should be made of a non-conductive material, such as nylon, and they should be installed at regular intervals to prevent the cables from sagging or coming into contact with the conduits. In addition to maintaining proper separation, it is also important to protect the low voltage cables from physical damage. This can be achieved by routing the cables in a protected location, such as inside a conduit or cable tray, or by using a cable with a rugged outer jacket. If the cables are exposed to physical damage, they should be protected by a conduit or other suitable enclosure. Alternatively, independent support methods can be used to support the low voltage cables. Cable trays are a common method of supporting cables in commercial and industrial applications. Cable trays are typically made of metal or fiberglass, and they provide a continuous support surface for the cables. Cable trays can be mounted to walls, ceilings, or floors, and they can be used to support a variety of cable types, including power cables, control cables, and communication cables. Wire mesh is another option for supporting low voltage cables. Wire mesh is typically made of galvanized steel or stainless steel, and it provides a flexible and lightweight support surface for the cables. Wire mesh can be used to support cables in a variety of applications, including suspended ceilings, underfloor spaces, and open-air environments. When using independent support methods, it is important to ensure that the cables are properly secured to the support structure. This can be achieved by using cable clamps, cable ties, or other approved methods. The cable clamps or ties should be made of a non-conductive material, and they should be installed at regular intervals to prevent the cables from sagging or coming into contact with other objects. In addition to following the NEC guidelines, it is also important to follow any local electrical codes and manufacturer's instructions for proper installation. Local electrical codes may have additional requirements for Class 2 circuits, such as specific wiring methods or grounding requirements. Manufacturers' instructions may also provide specific recommendations for installing their products, such as the proper torque for tightening connectors or the minimum bending radius for cables. By following all applicable codes and instructions, it is possible to ensure that the Class 2 circuits are installed safely and reliably. It is also a good practice to keep low voltage cables separate from power cables to minimize the risk of interference. Electrical interference can occur when low voltage cables are run in close proximity to power cables, causing unwanted signals or noise to be induced in the low voltage cables. This interference can disrupt the operation of sensitive electronic equipment and can even damage the equipment in some cases. To minimize the risk of interference, it is recommended to maintain a minimum separation distance between low voltage cables and power cables. The separation distance will vary depending on the voltage and current levels of the power cables, as well as the sensitivity of the electronic equipment being powered by the low voltage cables. In general, a separation distance of at least 12 inches is recommended for power cables operating at 120 volts or less. For power cables operating at higher voltages, a greater separation distance may be required. In addition to maintaining a separation distance, it is also recommended to use shielded cables for low voltage circuits that are susceptible to interference. Shielded cables have a metallic shield that surrounds the conductors, which helps to block electromagnetic interference from external sources. The shield is typically grounded to provide a path for the interference current to flow, preventing it from being induced in the conductors. When installing shielded cables, it is important to ensure that the shield is properly grounded at both ends of the cable run. This will provide the most effective protection against interference. Use designated cable clamps or supports to secure the low voltage cable along the conduit. Designated cable clamps and supports are designed to provide a secure and reliable means of supporting cables along conduits. These clamps and supports are typically made of metal or plastic, and they are available in a variety of sizes and styles to accommodate different cable sizes and conduit types. When selecting cable clamps or supports, it is important to choose a product that is compatible with the cable and conduit being used. The clamp or support should be sized to fit the cable snugly, without causing damage to the cable insulation. It should also be made of a material that is resistant to corrosion and other environmental factors. When installing cable clamps or supports, it is important to follow the manufacturer's instructions carefully. The clamps or support should be installed at regular intervals to prevent the cables from sagging or coming into contact with other objects. They should also be tightened to the proper torque to ensure a secure connection. Finally, remember to follow all local electrical codes and manufacturer's instructions for proper installation. Electrical codes and manufacturer's instructions are designed to ensure the safety and reliability of electrical installations. By following these guidelines, it is possible to avoid common mistakes and ensure that the electrical system is installed correctly. Local electrical codes may have specific requirements for Class 2 circuits, such as specific wiring methods or grounding requirements. Manufacturers' instructions may also provide specific recommendations for installing their products, such as the proper torque for tightening connectors or the minimum bending radius for cables. By following all applicable codes and instructions, it is possible to ensure that the Class 2 circuits are installed safely and reliably. To summarize, when working with 24 volts lighting control bypass switches and Class 2 circuits, adhere to these key points. Firstly, understand that these circuits are classified as Class 2 due to their voltage being less than 100 volts, primarily used for control and signaling. Secondly, ensure that if strapping the low voltage cable to power conduits, the conduits are grounded, the low voltage cable isn't touching power conductors directly, and it's protected from physical damage. Thirdly, remember that independent support using cable trays or wire mesh is also a viable alternative. It's also advisable to keep low voltage cables separate from power cables to prevent interference and to use appropriate cable clamps for securing the low voltage cables to the conduit. Lastly, always adhere to local electrical codes and manufacturer guidelines for safe and proper installation.